Hello everyone. I am Rabia. I will present today our extra assessment tasks. So before we start, the first task or the third task here is about the simulink. Suppose that the vehicle has a mass of 1000 kilogram and coefficient of friction B equal 150 Newton second per meter. Define the transfer function G. So we have uh, first task, task 4, which is 1, the number of coefficient, and then you have to enter the mass and then the P here, or the coefficient of friction. So now you will just run it and see the result. Okay, task 4, using MATLAB, plot the step response for the 60 seconds using the step functions input, set time, initial value, final value, and sample time 0. Okay, this is step initial and sample time 0. So this is the conditions of our task 4, and this is the results for it. And now we will continue to the another one, which is the task 5. Okay, we need just to move this and task 5. So in task 5, he asked about, let me just read the task. I want to open the Word file. Okay, he said what is the maximum speed achieved by vehicle with this input, which is input is 1 Newton force applied to 1000 kilogram vehicle. The maximum speed is very low, increases the force applied to the vehicle to 5 thousands, multiplying the transfer function by 5,000. Then recompute the step response. Okay, our step response will be run, and this is our graph. And he said what is using cursor measurement, which is this measurement, we will get the maximum speed is 33.33. If you want to show the other inputs, you can just show panel and see the results. You can move this and uh, just screen cursor. Yeah, now you can see the results. Okay, now let's continue. He say what is the maximum speed in mph? This is you want to multiply 33 or the results here with the 2.237, and then you will get the value of the maximum meal per hour. Okay, now let's go to uh, task 6. He said use the actual vehicle data provided in supporting files. Uh, okay, he asked about the or specific uh, Excel files. So we'll go to the text or task 6. In task 6, just to let the laptop render it. Okay, you have here uh, a spreadsheet or block parameters. You should put parameters as of Excel files, which is given by a doctor. And then he said name it to sheet 1. I name it to sheet 1. Then apply your parameters. You should first get the parameters values from the task and you found it. We found it as 1,030 and 310 and 250. The parameters also step one, final value one, and then you should run it, and you will get the result. What is the result? You see the transfer function and the from sheet is the same. If you run this, is the same graph here. Uh, we need just to change it. So change what? Change the sheet to VD. I think it's VD10. Let's just open the task. Task V10. Yeah. I spread it to make it more quickly, but I think the renders take more time. Okay. Uh, I don't want this graph. Okay. Here we have the Excel sheet, which is VD10, and the value should be 10 of the gain. And then we should run it and see the results. Okay, it's not so weird. No. Okay, we have a code error here. He said file VD is not exist. So we got it again from here, and you will see this VD10, upload it and okay, apply. Then you run it again. It's take much time. Okay, this is our results. The another one is also the same. So increase the input gain and compare the simulated response with the new data. The simulation still follows the fence trend and reaches similar steady state speed. But in the task, let's see task 6, but with 5,000. Okay, okay. Let's check. Okay, the same error. Just re-input this well and apply. Okay. You should change the gain values also, as we did in the last one, as the results. So here the gain was increased to 5,000, and now the simulated model no longer matches the reference data. The difference becomes larger because the real vehicle is non-linear, especially at high force, while the transfer function model is linear. This explains why the model accuracy decreases for large inputs. And now let's go to step response. Step response here, task 7. He asked about to calculate, he said, what should the step input be multiplied by for velocity transfer function to reach top speed of 50 mph equal to 24 meter per second. Okay, with no gain, 6.66 multiplied by 6 over our power minus 3. We should multiply by gain, and gain should equal to 1024. Okay, the results will be 3,363.36 in our reports. So you should run, and this is our results. So what our results says, show the graph show the step response after calculating the required gain. The speed curves are emergency settings around 22.4 meters per second target. Uh, task 8, we will move to task 8. Just let me read the task 8 for you. Okay, let's run task 8. Okay, task 8 said open the reference function vehicle models has been validated in task 6 and implement a simple gain open loop controller to do so. Add more or delete blocks so that the matches Simulink. Okay. He want to match a Simulink model. He gave it uh, in the experiment or in the report. So you just want to add gains and to make it similar as a set point and so on. Okay, let's go to task 9. He said set the control gain 100 does it vehicle reaches a set point of 550 beach. So task 9, if you have 50 and the gain 100, just run. And if you use measurement and see the bundle, you will know it's not reaches 50 mph or mile per hour. So task 10, identify the value of the control gain that causes the vehicle to reach top speed of 50 mph per hour. This can be accomplished by adjusting the gain value and running the model until the maximum speed recorded by the scope. Try to get gain value within. Okay, but it does not need to be closer than that. So he want you to try to get the value of 50 mph per hour. So if you try and try and try again, he said you can just add value 1 and minus 1 to get to minimize the 50 mph per hour. So here we found it as 100 111. You will run it, and if you want to check your results, you should just make the measurements and take the measurements here. You will see the value of 50. So uh, in task 11, suppose that the plant is linear and the gain is set to the value you identified in task 3. If the set point is changed to 70 mph per hour, what top speed will be reached? If you if you increase the top speed, so here there was no gain that was specified task 3, so we'll use gain as 1. So here we will change the value 70 and the gain 1. Then we will start to run it and see the results. Use your cursor rule. Okay, first you need to just adjust your axis automatically. So you just should adjust your grid here to let you know and change the limits. So uh, this is the velocity or not velocity around. So here should be 10 or 100, not 10. And then you will run this to see what is your results. Just make the scoop and access automatically. Then you'll show or see, not so, the result. If you want to measure the mere per hour, you need measurements, show panel, and run this. You will see you have reached the maximum. You will, okay. Now with task 40. For task 12, we should repeat it again with 70. But we will go to the task 4. Open the task and function vehicle models have been. He asked here to put feedback, and you should put here one in minus and one in positive and one in negative. KB is 1 and the function you found before. And he asked for the set point of 50. And then you will run the measurement to see what you will get. Okay, again, you need to set the graph. Uh, just bring this to axis from 0 to 1 and measurement just move this here and then you need to run Chobanov to see the values of the maximum, which is set to 60 and 1 with the first point here. Okay, and for task 15, he said run the model and observe the input output, which is what we did now. Okay, so task 16, the speed reached by vehicle is nowhere near the set point 50 mile per hour the input virtual vehicle model has units of network so gain of 1 so for too low to achieve the desired set 5000. The model is maximum. Okay, this is task 16. He said you have 5000 KB and he need the result. So we run it and see the result. This is different graph. For this graph, if we want to explain what we have got here, this graph shows the behavior of the proportional closed loop control. The vehicle body moves because the control sign is too weak. When I increase the proportional gain to 5,000, the vehicle speed approaches the set point of 50. Unlike open loop, the closed loop controller corrects itself using feedback. So the closed loop with the feedback will correct itself using its feedback. For task 17, task 17 he asked about try several different set points with the game value. Does the feedback control work across broad range of requested speeds? So I want you to choose to change these values. In the task, we change it 20 and 100. So running with set point 100, the speed was is 97.8. The values clues are close yet not exact, and it was noticed that when the set point is set to be low, the results are closer the set point, and the results when the set point is high. And now the last one, if we add the scope connected to the control signal, what is the result? So run, and this is the result will be. Before it will started from zero, it here started from up and like decreases proportional uh, function. And that's what we have for MATLAB.